Okay, part of section 4 in chapter 7. I had you guys do a little bit of this when I was gone. I don't know if you really did. And it had solving identities. We've done some identities before, like when we used the Pythagorean triples and that. Now we're going to start using the double angle and half angles to solve these. Well, if you did, then let's see if you can figure this out. 1 plus cosine of 2a equals 2 over 1 plus tangent squared of a. We'll work on this one together. Actually, I'll work on 2 of them for you. And we have to, it's kind of like proving them. We're going to prove that this here equals that there. Well, it's really not. It's like a proof, but it's called finding identities. It's okay. Yeah, I know. I don't care for proofs either. But anyway, so I'm going to look at this, and there's a couple things that right away when I look at this equation, it's going to stand out for me. One, I know that cosine of 2a, if I look up there, it's either cosine squared of theta minus sine squared, or it's 2 cosine squared minus 1, or it's 1 minus 2 sine squared, right? It's one of those three, and I'm not sure which one I would want to use. So we can do a trial and error, you know, trying them in there and see which one we'd figure out. But I'm not sold that I know which one I want to use there yet. So I'm going to take a look at the other side of the equation. All right? And I see a tangent squared here. Well, what I can do with a tangent squared, a 1 plus tangent squared, is I can make this over here 2 over 1 plus sine squared a over cosine squared of a. Okay? And actually, I can even make that easier yet. I didn't realize this till I was just looking up there. If I look up under the Pythagorean identities, what does tangent squared plus 1 equal? Secant squared, right? Let me do it this way. If I make this secant squared of a, well, secant squared is 1 over cosine squared, right? So if I'm 2 is 1 over cosine squared of a is the same thing as writing 2 cosine squared of a. Invert and multiply. Well, now I've got 1 plus cosine 2 of a equals 2 cosine squared of a. Invert, multiply. Take a look at my double angles. 2 cosine squared of a minus 1 equals cosine 2a, right? Subtract 1 from both sides. This goes away. And I'm left with cosine 2a equals 2 cosine squared a minus 1, which is my double angle identity. Michael, you look kind of confused when I said that. You know what I did? And it comes down to, I got 1 of 3 choices on my cosine 2a. I didn't know which one I wanted to use, right? So I'm going to look at the other side of it. And actually, when I did this earlier, I put the sine over cosine for tangent. And then I brought the cosine across, you know, made it cosine over cosine. So it was cosine plus sine squared over cosine squared. I did all that stuff instead of looking up there and saying, well, let's see, tangent squared plus 1 equals secant squared. So I actually did more work when I did it earlier than right there. But I came up with this. This is it. Because right here, I mean, this is one of your double angles right here. That shows a double angle. That's number 29 on page 382. Number 29. Okay. Any questions on that? Let's take a look at number 30. Cosine squared 2x plus 4 sine squared x cosine squared x equals 1. You just cross it out, make this 1. And what can you? What is it? Well, you know, you're close in what you're doing here. You're looking at it. If I looked at this as saying, no, you can't add these together. No, it's 2x and that's x. So you can't add them together. No. Look at the Pythagorean identity. What's the original Pythagorean identity we look at? Sine squared of theta plus cosine squared of theta equals 1. Well, I've got cosine squared, and it says 2x here, like it's a double angle, but I could call that theta, couldn't I? 2x, I could call theta. It's still just an angle, right? So what do I need over there? I need a sine squared. All right, so I got 4, but what if I did this? I'm going to leave this here, squared 2x, plus, I'm going to square this. I'm going to square what's in here. So if I take the square root of 4, it's 2. If I take sine squared and I take square root of that, it's going to be sine of x. And this is going to be cosine of x, right? What is 2 sine of x cosine of x? What is it? Sine what? Cosine squared 2x plus sine squared 2x. Actually, let's do this so you understand what I'm doing. Sine 2x squared equals 1. Okay, I just replaced my sine of 2 sine x, cosine x with sine 2x.
Well, now we just prove that now you got to take out and make that go away.
Cosine squared 2x plus, and I square this, sine squared 2x equals 1. Now my 2x can just be a theta, right? Right? So it'd be like saying cosine squared of theta plus sine squared of theta equals 1. And that's our original Pythagorean identity. Is that better? Okay.
Why do you write your 2's different?
I don't know. Sometimes I write G like this, sometimes I write it like this.
What? How is the other one a G at all?
Cursive.
Oh! I can't write anything in cursive except for my name. So.
All right. So this is number 30 here, guys. what you've got to do, you've got 33 through 38. 33 through 38, page 382. This is what you've got to do.